For decades, Intel has dominated the microprocessor market, but for the first time in a long time, it's looking like there's a real threat to them. Today we're going to talk about what their current challenges are and what they're doing to meet them. Welcome to Kopec Explains Software, the podcast where we make computing intelligible.
This week we're talking all about Intel and their current challenges, but I'm wondering, how did they become dominant in this space?
Intel first rose to prominence making memory chips. They slowly moved into microprocessors, and they really had their big break with the IBM PC. The IBM PC ran an Intel chip called the Intel 8088, and this was based on an architecture designed by Intel called the x86. We have talked about the IBM PC and why it became such a standard in a previous episode, which I'll link to in the show notes. But basically, the standard for all personal computers became based on an architecture that Intel designed. So Intel became the dominant maker of microprocessor chips for all personal computers. There were, of course, some oddball manufacturers that didn't use Intel chips or Intel-compatible chips, such as Apple, for example, but the vast majority of manufacturers have been using Intel chips for the past 3 to 4 decades. Intel has licensed the x86 architecture to a few other companies over the years, including their arch rival today, AMD. But Intel still has a majority share in the microprocessor market for PCs and laptops and servers. It's a whole different game when we talk about mobile devices like smartphones. Those are generally based on another architecture known as ARM, and I'm sure we'll get into that later in the episode. But to answer your question, basically the way that Intel came to dominate is their microprocessor architecture, x86, became the de facto standard for personal computers and servers, and therefore Intel's chips became the dominant player in personal computers and servers as well.
Okay, so talk to us a little bit about the landscape now. How is Intel doing?
Intel, in many ways, is still doing very well. They're making a huge amount of revenue. I just looked it up. I think it was $80 billion last year. They're making a huge amount of profit. They made about $20 billion of profit last year. Their market cap is over $200 billion. The company's doing very well by all of those measures. But that's if you're really not looking at the whole competitive landscape. They've actually been losing market share in PCs and servers to their arch rival AMD over the course of the last few years. They also lost an important contract with Apple. Apple went from using Intel microprocessors in its personal computers to using its own design microprocessors that are manufactured by Taiwan Semiconductor and are based on the ARM architecture that I mentioned earlier. So if you just look at the raw numbers, it looks like Intel is looking pretty good. But if you look at the threats that they're facing from all kinds of different areas, there's actually quite a bit of dysfunction there. And they also have had a lot of trouble getting to what's called a smaller node. In the world of microprocessor manufacturing, it's all about how small can you make the transistors. And Intel is one of the 3 largest fabricators of microprocessors in the world, along with Taiwan Semiconductor and Samsung. They're one of the big 3, but they've had trouble getting to as small a node as Taiwan Semiconductor and Samsung have gotten to.
And why is getting to a small node important or powerful?
The more transistors that you can fit on a chip, the more powerful you can make the chip. And so the smaller you can make those transistors, the more that you can fit. And we've talked about this on some previous episodes, so I won't go into it in a huge amount of detail, but basically Intel's been stuck at a node known as 14 nanometers for several years, and they were just having trouble getting down to a smaller node that's their 10 nanometer node, and they have gotten there now to 10 nanometers. In the meantime, their competitors like Taiwan Semiconductor got down to 7, then 5, and are currently working on 3. And there's controversy around why a node from one manufacturer may not be the same as another. So for example, some people say that a 7 nanometer Taiwan Semiconductor is the same as a 10 nanometer Intel. But no question about it, they've been stuck at Intel while these other manufacturers have continued to progress, win contracts, and actually have more performant chips. For example, when Apple's microprocessors for their Macs came out last year, they blew out of the water in single-threaded performance a lot of the current Intel chips at the time. So there's been real implications for this, and the other big problem that Intel's had is they never made a real dent in the mobile market, and I'm talking about smartphones and tablets. You will find very, very, very few smartphones made in the last decade that have Intel CPUs in them. Sometimes they'll have other kind of Intel components in them, but very rarely Intel CPUs. So this is, of course, the big market in computing now, right? Is these smaller devices, is these devices that are running a completely different microprocessor architecture than the one that Intel had their dominance from. So while PCs and servers continue to mostly use that x86 architecture, in fact, a newer version of it called x86-64 that was actually designed by AMD, but again, that's too much detail, most smartphones, tablets, and other small devices use ARM architecture microprocessors. This is not a market that Intel is even in. Ironically, they were in the ARM market back in the late 90s, early 00s, and they actually sold off that part of the company, which was a big mistake. Yeah. And, there's even this great story where when Apple was coming out with the iPhone, Apple went to Intel and said, hey, can you provide us a chip? And Intel was like, here's what we have on offer. And they didn't want to come up with a custom mobile chip just for Apple. Big mistake. They lost a lot of potential sales, but maybe they didn't know the iPhone would be as big as it was going to be, of course. But anyway, they really have messed up in mobile. They haven't had a real competitor in the mobile space that's as power efficient or as powerful as the chips from all of the different ARM licensees. And that's one of the big differences also between x86 and ARM. I said licensee because Intel's the originator of the x86 architecture and also the biggest manufacturer of x86 microprocessors. On the other hand, the ARM ecosystem has a company called ARM that actually designs the microprocessors. But then there's a lot of other companies that license those designs, modify them, make their own versions of them, basically are just licensing the architecture, and then have them manufactured by Taiwan Semiconductor or Samsung or other big fabricators. So it's actually a much more open ecosystem, whereas on x86 you just have Intel and AMD, who for historical reasons have an x86 license. On the ARM side, you got all kinds of different manufacturers. Everybody from Taiwan Semiconductor to Samsung to Texas Instruments to a bunch of companies that are designing their own versions of these chips, like Apple or like NVIDIA. And it's a really competitive landscape, whereas on the x86 side, you only have really two companies. And so when AMD does well on the x86 side, that means Intel does not do so well. Although they're still collecting licensing fees, presumably.
One of the things that's important about Intel is that they make their chips here in the States, correct?
Right. This has become important because of trade issues. So Intel is the last cutting edge fab in the US. The other two cutting edge fabs are the ones I mentioned earlier, Taiwan Semiconductor, which is in Taiwan, and Samsung, which is in South Korea. So in the last few years, there's been these trade disputes and there's been kind of a push to control the semiconductor industry on a country-by-country basis. For example, China is investing a lot in semiconductors and trying to have their own fabs as well. The US's last cutting-edge fabs are the ones that Intel owns. There is apparently going to be a new fab from Taiwan Semiconductor in the States, but Intel is really the only homegrown company that has cutting-edge fabs. It used to be that IBM and also Global Foundries, which are two other American companies, had cutting-edge fabs, but they really are bit players today and not really in the same ballpark to the big three. So yeah, it's become kind of a nationalistic issue, become kind of a trade issue, and Intel is really the last hope for the United States to have a cutting-edge fab that's also from a homegrown company.
How do these chips play into the software world?
Yeah, so there's a lot of lock-in. When you make software for a particular microprocessor architecture, it does not run on other microprocessor architectures as a general rule. There are such things as what are called universal binaries, but most software is just made for one microprocessor architecture. So if you make software for x86, for example, a chip from Intel or from AMD, it'll run on both Intel and AMD chips, but it won't necessarily run on Apple's new chips, or it won't necessarily run on the chip in your smartphone. There's a lot of lock-in. For example, Microsoft Windows is mainly sold for x86 PCs. Now, a new threat to Intel is actually that Microsoft has come out with a competitive version of Windows for new ARM microprocessors from companies like Samsung. So even Windows is no longer a mainstay of just Intel chips. However, it's likely that for the foreseeable future, most Windows PCs will still be on Intel or AMD chips. But there's a lot of lock-in here, and it goes back the other way too. So you can't take a current version of iOS, for example, for your iPhone and run it on an Intel chip. It just won't work. It only is compiled for ARM microprocessors. So these architectures have kind of a moat around them because the software that's already come out for those architectures keeps people in the ecosystem of those architectures. It's a much bigger move to go and get software now for a totally new architecture. And it's work for software developers to go and take very sophisticated pieces of software and move them from one architecture to another. If it's a trivial piece of software, it might be a simple recompile. But for anything that's kind of sophisticated or that has any kind of low-level component to it, there's going to be more work involved. So Intel has this great moat, and AMD too, around the x86 architecture, but it's starting to be eroded by moves by Microsoft, moves by Apple, and by the general movement away from desktops and laptops to the mobile ecosystem that's been going on for over a decade. Even in the server space, we're starting to see some ARM microprocessors really make some headway. And there are other architectures too. These are just the two dominant ones. There used to be a lot more common architectures. If you go back to the 1990s or even the early 00s, maybe you've heard of things like Itanium or Spark or MIPS. Just today, really, the two architectures left standing are x86 and ARM. There's a new one on the horizon called RISC-V, and it's actually an open architecture. You don't need to actually pay licensing fees to use RISC-V, and we'll see what happens with that if there's really high power microprocessors that come out for RISC-V. But right now, if you want to build a desktop PC or a laptop, you're going to probably use an x86 chip because that's where the software is. And if you're going to build a smartphone, you're probably going to use an ARM chip because that's just where the best chips are. Even though Intel does make some chips you technically could use, you're probably going to use an ARM chip. And that also is where the software is. Even though Android does have an x86 version, the most common version of Android is for ARM. And so that's where most of the apps are too.
So what's going on with Intel now? They've got some new leadership?
Yeah, in my opinion, they've had some bad leadership for a number of years now, but they have a new CEO who really seems a lot more on the ball, and he's making some big changes.
Like what?
First of all, to address the problem of Intel being behind on its node, he's actually going and saying, hey, we're going to actually outsource some of our production. That's hopefully a temporary measure for them, but he's going to actually let some Intel microprocessors and products be made on competitors' nodes like Taiwan Semiconductor. Another thing he's doing is to kind of spur innovation in their own nodes. He's going to start licensing out some of their capacity to microprocessor design firms who want to have their processors built maybe on a node by Intel instead of sending it out to Taiwan Semiconductor or Samsung. So he's actually going in both directions at the same time, saying, hey, we want to get some more excitement about our own nodes, push ourselves. So we're going to bring in companies that want to use our capacity. And we're also going to send out some of our work to the companies that we're acknowledging are on a better node right now than we are. So that's some really exciting stuff that's going on the fab side. Then on the product side, they also have some new architectures that are pretty exciting that are coming out. They're working on a discrete graphics card. They've done graphics work before, of course, because most Intel microprocessors have integrated graphics in them, but they've never had discrete graphics that are really competitive with the cards that come out from AMD and NVIDIA. They're actually going to be coming out with some competitive cards in the next year. So they're entering some new markets. They've unsuccessfully, to be fair, tried to enter a bunch of markets over the last decade. But I think that these are much more concerted efforts that they actually have a lot more experience in. And I think they could definitely be successful in both of these areas, both licensing out their fabs to other companies and also getting into the graphics market in a more serious way. So I want to just give full disclosure. I'm optimistic about Intel. I actually bought a significant amount of Intel stock yesterday. So I am, and this is recorded on a Friday, so I wasn't buying it on a Sunday when the day before our episode comes out. But yeah, so I'm kind of bullish that they can turn things around. And the thing is, there's a lot of doomsday stories out there about Intel. But the truth is, they're still a very, very profitable company. They're not going anywhere. They still are I just checked the market share. They still have 60% market share in the x86 space. AMD's been growing a lot, and they're at about 40% now, which is a far cry higher than where they were before. But Intel is still the dominant player in x86. They're still extremely profitable. And now that they have new leadership and they're making some real changes, I think there's some real hope for their future.
That's exciting.
For them and for my stock.
Yes.
All right, thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
Thanks for listening, and we'll see you next week.
Bye.